heard about the trophies we printed. Here I'm going to tell you a little bit about what else we're going to print and what is really about 3D printing. And at Monash, we actually have the best, the largest 3D printing machines in the world, really due to the visionary, our senior managers, including Professor Jens Smith here. And everything really is attributed to the team. Without a team, I only have a pair of hands. Here, my team achieved a significant output. We are 4 components for French engine company Safran passed the engine test in 2014. We were awarded Top Innovation Award. And also, we presented a full-size engine printed in our center in 2014 as well. And since then, we now formed a commercial partnership with this company to produce commercial product use 3D printing in Safran and Toulouse. So how does 3D printing work? First, we take a design, a computer design. You see the Vasky model. And then the computer will slice the computer design into 2D sections. And you put the 3D printer, the laser will start to work. And after finished, the layer by layer build up component, we just remove the powder, you see the product. Here's illustrating how the laser is melting the lead powder, metallic powder on the bed, and following the path defined by your CAD file or computer design to melt the material, solidify, and layer by layer, and you will see a 3D net-shaped product afterwards. Just shake off the powder, you see the product. Of course, to make it work in engineering side, we need a subject that's to heat treatment to engineer the microstructure property. And the biggest advantage of 3D printing is really about weight reduction. On the top left is a conventional cast titanium hinge for A380 aircraft. And in this aircraft, there are 1,700 hinges. So you can imagine by redesigning it, reduce the weight, we can significantly reduce the weight of the aircraft. And here are some examples we can make in the 3D printing. It's very complex. You can draw whatever you like, and the 3D printing will be able to print it. Even in the past, we couldn't do it. Machine it or through casting is impossible, but you can do it. In terms of engineering application, there are a lot of applications. Now here is a die. We know actually the mobile phone case is made by this die. But if you introduce cooling, you can extend the die 3 to 5 times the life of the die. So we'll produce a lot more components. And the biomedical application has been more exciting. And you actually can make bespoke components, implants, but also you can make tools. The doctors have designed the tools. They just want to make a couple of sets. And on the left, actually, is a keyhole surgery, spine surgery tools designed by a doctor. We designed, the manufactured, reduced the operation time significantly. Of course, the implants, whether it's a skull or a hip or other part of the body, they've been a lot being used in human bodies across the world. From a concept of a car to a final car, you probably don't know, actually it takes 6 evolutions. In the past, these 6 evolutions will take 2 or 3 years. With 3D printing, to print the design, instead of 2 months or 3 months, now it's just 2 hours. You can design the car in 3 or 4 months. And the commercial application now has started. And the GE and the Safran engine, you probably know, it powers Boeing 737. Actually use this to produce the most complex nozzle. And this nozzle traditionally takes 16 steps to make, now just 1 step. And also, by optimizing design, you can increase the fuel consumption. So does really 3D printed component work in engineering? It does. If you make an engine fire it, actually it does work. And this moment, we're actually now making a lot of components in aerospace industry and use 3D printing. In the past, we designed from design engine to final design, it would take 15 years, now only take 3 to 5 years. You can also use 3D printing to do repair, to clad, to add wherever you wanted it for corrosion resistance or wear resistance, or repair where it's worn out, to reclaim the component as new. So that's what we use. It can be any size, can be like mining tools, or can be aircraft or landing gears. That's what we are doing in engineering. What is the problem with 3D printing? Why can everybody do it in your garage? But problem actually is like casting or forging conventional, a lot of materials issues. So we have to understand how the process parameters affect the materials, microstructure and the property, and trying to get it right to meet all the property requirements so you can fly. And in 2015, my team and I successfully qualified a 3D printed process and the titanium components in civil aircraft. Now they are implemented in a civil aircraft and started flying. How to 3D print functional metal parts? And we really need to work with materials scientists to get the right process parameters for your material. And you need to redesign it to maximize the cost and the performance benefit. You can't do it in your garage yet, I'm afraid. It is still too complicated. It's not like the toys, the plastic 3D printer we are working on. Monash covers a full range of research for 3D printing, from design to the material, to the process, and to the qualification. We also conduct training for engineers and the students. So if any of you wish to be trained, please come to Monash, we can help you. To finish off, 3D printing really totally opens up design freedom. So this would revolutionize in manufacturing industry. Basically, whatever you can draw, we can print. And the aerospace industry benefits the first because their components are very complex and also competition is extremely high. 3D printing biomedical device or implants actually is extremely easy compared with engines. The challenge really is about certification, the process, and which takes a lot of time and also a lot of money. And the country explore the technology application most will have the biggest market in future. I hope Australia is the country and Victoria is the place.